Welcome, welcome. I'm JJ. Let's do a quick example problem. So again, we're starting on statics. We typically start that talking about law of sines and cosines, or the parallelogram rule, or the tip-to-tail rule. It's all the same thing. Let's come in and do our example. Let's use the law of sines and cosines to determine what's our magnitude and direction if we are looking for the resultant of f1 and f2. So tackling the parallelogram rule, so we can do law of sines and cosines, let's make our parallelogram. So I'm going to take f1 and just slide it parallel, draw it again a second time so we can get a third side of a parallelogram. I have two sides right now, I need four. So I'm taking f1 and I'm sliding it so that the tail, the side without an arrowhead, touches the tip of f2, the side with an arrowhead. So sliding that just parallel down, I take it from here and end up about like this. So I'm going to there. So I can get this parallel line drawn in here. It doesn't need to be exact. Just get something that's loosely correct. Getting loosely the right dimensions in there or the right angles will make everything easier to check our work, visualize what we're doing. If I do that with F1, this is still F1. I'll come in and label that. And I have F2. I'll do the exact same thing. I'm taking it and sliding it so that its tail touches the tip now of F1. So taking F2, sliding it up, we're going to get something that goes like this. Coming down here. So I have the two tails touch, the two tips touch. This is F2. The diagonal across this from the tails to the tips, that's my resultant force. So let's come in and label that in here. My resultant goes like this. And I'm going to call that FR for the resultant force. FR. I'm trying to find what's the magnitude here, and eventually, what's my angle from FR down to my positive x-axis, or to an x-axis. For this one, it's the positive one. I'm looking for FR and theta. My final answer is just going to combine those into one statement to get through everything in here. So let's go ahead and try to tackle that. So if I'm doing this, again, my general approach for this is figure out FR first. Use the law of cosines. Then we can work towards getting theta using the law of sines. To do this, though, I need to first figure out what does this triangle thing tell us? Well, really, it's my ratio of height to base to hypotenuse in here. Let's add one more angle in here from horizontal down to F2. Let's call that angle alpha. And if I know my ratio of height, base, hypotenuse in here, I can find alpha. Really, let's label a quick triangle. I have this triangle right here. This is 3, 4, 5. And this angle is alpha. Because if we have a box, we could also say this is 3, this is 4 on the top. This angle would also be alpha. So I only need one side of that to get alpha, but I can work with that. I know 3, 4, 5. I can use any one of my trig identities in here and say, well, my tangent of alpha, tan alpha, should be, tangent is defined as always opposite over adjacent. So 3 over 4, or using it up here, 3 over 4. Either way, it's the same angle in there. Tangent of alpha is 3/4. The inverse tangent of 0.75 is what we really want to use here. This will get us to alpha is the inverse tangent of 3/4, 3 over 4. Or alpha is going to be equal to 36.87 degrees. So I know this angle alpha. We're trying to build towards figuring out what's the angle opposite FR, which would be this angle right here. If we're going through this, let's get another angle in here. Let's call this angle, if I project out this 1,000-pound force, let's label this angle. That angle for me from F1 to 1,000, from F1 to 1,000, I'm going to call that one gamma. Gamma in here. The other side from F2 or from F1 backwards to my 1,000, this one, we'll call that beta. And I can get gamma easier than beta in here. But if I get gamma, I can find beta. That's my angle opposite, FR. It'll get me what I need to use the law of cosines. So how can I get to gamma? Well, I know gamma is from my 1,000 up to F1. I can work with that here, from 1,000 up to F1. Well, that is 60 degrees plus alpha in here. Two things, I just need to add them together. So this is 60 from F1 to horizontal plus alpha from horizontal down to F2 is exactly what gamma is doing in here. Or this is 60 plus alpha, 36.87 degrees, which will get us that gamma is 96.87 degrees. If I know gamma, I can find beta because beta and gamma are supplementary. They have to add to 180 degrees. From F2 to a line that continues past the end of F2 is 180. So beta is 180 minus gamma for this problem. Or this is 180 minus 96.87. Beta is going to work out to get us to 83.13 degrees. Finally, that is my angle opposite FR. FR touches this angle here, this angle here. It doesn't touch beta though. So I can use it in my law of cosines to get my resultant force's magnitude. FR is the square root of one of those sides squared, F1 squared, 1,500 squared. 1,500 squared. Plus the second side, F2 plus 1,000 squared. Minus 2 times F1, 1,500. Times F2, 1,000. Times the cosine of the angle in between these two sides. Cosine of, which the angle in between them is beta, the same as the opposite angle as FR. Cosine of 83.13 will get us that resultant force in here. FR is 1,700 pounds. So I have my magnitude, I need direction, and again, I'll pull them into one answer statement at the end of that then. So let's go ahead and try to tackle that. So I have FR. I can use that with my law of sines. Let's come and label another angle in here. We can call this phi. Phi goes from F2 up to the resultant force in this. Or phi is this angle right there. My angle phi. I can use that and then subtract off alpha will get me from horizontal up to the resultant force. But I can find phi using the law of sines. Then my sine of phi divided by the angle opposite that, or the side opposite it. If phi is right here, the opposite side is F1, 1,500. Should get me to, well, I know beta and FR. Again, this is why I start with law of cosines, because then I have a side and the opposite angle. I can use in the law of sines. So this is equal to sine of beta, sine of 83.13 divided by the opposite side, FR, 1,700. I need to move that 1,500 to the other side and just take the inverse sine. And I'll get here that this gives me phi equals 61.14 degrees. Which finally I can get to theta from that. If phi from F2 up to FR is 61.14, that's the same thing as alpha plus theta. Alpha plus theta gets me that angle phi. So theta should just be theta is phi minus alpha for this problem. Or that is phi is 61.14 minus alpha 36.87 minus 36.87. Or my angle here, theta, works out to be 24.3 degrees. 24.3 degrees. So I have my magnitude, I have my direction, pull them into one answer statement, we can wrap everything up here. So my resultant force, Fr, as a vector now, so I'm going to stick a line over it, is my magnitude, 1,700. This angle just visually looks like it's measuring into the first quadrant. It is. So we'll show an angle symbol that looks like that, 27 or 24.3 degrees, 1,700 pounds. Let's get our units in there. But that would be my final answer for that one. Law of sines and law of cosines, well, we can do it. We're going to come back in later videos, probably in the next class. If you are in statics right now, your professor comes back and more or less says, law of sines and cosines, well, we can do it. If we have more than two vectors, it's brutal to do. There's a lot of chance we make a mistake. As engineers, we want to do things that mitigate how many mistakes we make because people die if we make mistakes. And there's easier ways to do this. So if this is a struggle for you, for me, geometry is one of my weakest points. The geometry to get through these is hard. You're not alone feeling that way. Get through it. You're probably going to learn an easier way next class. But we'll have videos up for those as well. Take a look at that. We'll actually redo this example problem using a different approach. But you can tackle this. Get through it. This is useful for you. Hit that like and subscribe. Let's get you an A with JJ.